Hi, this is Aashima. I lead a product and solution strategy for healthcare at Google Cloud. Truly an honor to be here with all of you today. First, I want to start by recognizing everyone joining this session. These are difficult times for all of us, and many of you are adopting to this new normal which is unwanted, unnatural, and frankly, none of us have ever experienced anything like COVID-19 before. Together, we will get past this. Yes, we will get past the coronavirus. It is my hope that we will come out stronger and wiser as a result of the pandemic that we are all going through. Thank you for doing your part in engaging in meaningful education despite the circumstances. I thought I will share a bit of I'll start my session with a bit of inspiration. Let me share a video on how we think the future of healthcare will look like with some of the latest advances in technology, especially artificial intelligence and machine learning.
Google has very good general speech recognition, but if you do not sound as most of people, it will not understand you.
No one's ever collected large data sets of people whose speech is hard for others to understand.
People who have multiple sclerosis, for GF, who had stroke, who stutter.
They're not used in training the speech recognition models. The game is to record things.
What's the temperature today?
And then have it recognize things that you say that aren't in the training set. Dimitri recorded 15,000 phrases. It wasn't obvious that this was going to work. He just sat there and he kept recording.
We need to make all voice interactive devices be able to understand any person who speaks to them.
You can see that it's possible to make a speech recognizer to work for Dimitri. It should be possible to make it work for many people, even people who can't speak because they've lost the ability to speak. The work that Shenxing has done on, voice utterances, from sounds alone, you can communicate.
So that was kind of an intro from how we see the world from the Google perspective. 1 in 17 searches in Google are healthcare related. Google is already present in our daily lives. More than 1 billion people turn to these Google tools for help and health, and it is no different. So when today you need information about medical condition or directions to the nearest hospital, reminders to take medicine, or help with measuring your fitness progress, you might turn to Google product or two for help. For many people, their health journey today starts with and continues with search. 1 in 17 searches in Google are healthcare related. And you come to us with wide range of questions, from what causes hiccups to what are the lupus symptoms to how to lower blood pressure. You come to us when you're well, when you're feeling like something is not okay, or when you're managing your condition on a daily basis. And you don't only come to search, you use Google Maps to find the nearest ER, or when your doctor office opens, you turn to YouTube for videos about cooking healthy recipes or stretches for lower back pain. You might even be accessing this information on Google's various hardware devices like Chrome or our Android phone. And thinking more broadly across Google, we have efforts that impact people's livelihood in so many other ways. For instance, I see our projects focusing on self-driving cars, with Waymo, literacy improvement, crisis response, and so much more as an extension of our promise. We'll continue to work across the teams and products to improve the information and tools that can help consumers, wherever you are in your healthcare journey. We also feel great urgency around getting our tools and work into the hands of clinician and patient, and also more importantly, many different enterprises around the world. These are the health systems, hospitals, insurance companies, pharma companies, life sciences companies, as well as startups. We believe as the industries at large are moving into the digital transformation, we believe that 3 big pillars for that democratization of innovation or transformation. The three pillars are democratization of technology foundation, democratization of machine learning, and democratization of patient records. So what are the resources that are accessible in today's healthcare enterprise environment to enable tomorrow's innovation? The first one is very important as the area I represent. I am from Google Cloud. The same infrastructure that powers many of our products today, be it Gmail, YouTube, Google Photos, Maps, the same infrastructure is now packaged up and available to the enterprises or to any developer, be it in London, be it in India, be it in any other place. It's no longer a Silicon Valley technology. It is available to anyone who wants to focus on innovation, and they can give the infrastructure task to us. This is what I call truly the democratization of technology foundation. It wasn't like that when I started my career 24 years ago, and when I was a student, and even when I was in between jobs and many different roles I played. Getting hold of that infrastructure took a long time. And the good news is now, as I mentioned, whether you're a startup, whether you're one developer shop or a two developer, a big enterprise with thousands of developers, it's a level playing field. You have the same infrastructure that is available to you through cloud. The second pillar I'll touch upon is machine learning, how we are working towards thoughtfully democratization of machine learning and what tools are available to you. And the third is the topic which is very near and dear to my heart. It is about the democratization of health records. And I'll shed some more light as we go along on that. When we talk about healthcare, health doesn't happen the 2 times you visit your doctor. Those are 20 minutes visit typically. And when we look into the concept of a total health, we have to focus when we talk about patient centricity, keeping the patient at the center. Your health is not just in your electronic medical records or when you visit the doctor, as I mentioned, it's a care continuum. It is where you live, what your zip code is, what is your lifestyle, how healthy do you feel, what is your nutrition profile, how active you are, what kind of lifestyle do you live, and all that together is a concept of a total health. It is not 24/7, sorry, it's not just episodic, it is 24/7 and across the care continuum. And how do you now connect the dots from a patient perspective? There's a strong belief by connecting all these dots from a consumer or a patient's perspective and creating the right intervention at the right time will lead to better outcomes. So when we look into today, we talk about a lot of mobile applications. When we work in how do you bring all this data together from a patient perspective. So take the case of Samantha. This is her health dashboard, and she has many different aspects coming together. Her insurance information, her appointment information, her medication information, as well as her electronic medical record information. As we are looking into creating this empowering digital experiences, all this data has to come together. And we believe by creating and providing that technology infrastructure, where I talked about the democratization of infrastructure, the tools are available to the community, the tools are available to the innovators, tools are available to the developers to bring all this information and data together so you can build powerful digital experiences to help patients along their journeys. At the heart of it is the concept that I call the secondary data layer, or where cloud and AI fit in. Today, when you are looking into bringing all this data together, it's a very complicated task. It is complicated because there are multiple different data modalities. We talk about EHR, we talk about membership systems, and the new innovation that are coming in, the wearable data, the remote monitoring now with COVID that we all have seen, and also the data from your imaging. For example, if you have gotten a chest x-ray done or an MRI done, they live in a very complete different data format and a different system altogether. How do you bring all of that? It's easier said than done, that to combine all this data, but we believe cloud is simply the better way to do it, to bring all this data together. So you can then create a record, which is longitudinal patient record from a patient's perspective, and you can see what has happened to that patient or how the patient is experiencing their health journey. So these are the helpful tools from a cloud perspective that we want to bring to the community. And these tools have to do with three things. A, ingestion of this data from different modalities. Second, bringing the data and normalizing that into a longitudinal record. And third is creating APIs so you can then create new digital experiences on top of that. In addition to that, especially in the field of healthcare, we are looking into bringing tools like de-identification. I'll give you an example here. This is very relevant because when you're looking into patient data, it's very sensitive. It's sensitive because it has personal information, and in many parts of the world, and rightfully so, it is protected health information. So we are building tools like de-identification to mask, delete, or otherwise obscure the data. If you look into the screen on the left-hand side, you see a chest X-ray with the PHI, which is imposed on the image. On the right-hand side, when you look into the images, the information has been stripped out. Now, de-identification has multiple use cases, including when you're sharing the health information with non-privileged parties, when creating data sets from multiple sources and analyzing them, and very importantly, what you've seen is anonymizing that data so that it can be used in creating multiple machine learning models. That way it is aggregated, it's anonymized, and you're learning from those images, be it the radiology images, understanding the different lesions, and it's, at the end, it's a pattern recognition without really putting the patient information on there. Opens up a lot of possibilities on how this data can be used in future. So then let me turn and shift gears on when you're looking into democratization, the machine learning for all. So we do it in two different ways. We are building the tools like Cloud Auto ML, which are the technologies that are available to developers to really ramp up and learn from these tools and assets, leverage them in their own environment, and build machine learning models. We are also looking in some cases, we go deep and build our own machine learning models, and we bring it to the community. So one example here is the diabetic retinopathy. It is one of the fastest growing cause of blindness. 415 million people with diabetes at risk for this disease. The sad part is this disease is preventable if it's detected early. As an example, India has shortage of 127,000 eye doctors. But the good news is the permanent vision loss is not inevitable. For those who are diagnosed early enough, medication, therapies, exercise, and healthy diet are highly effective treatments for preventing further damage. A few years ago, several of my brilliant colleagues at Google Health began wondering if there was a way that Google technologies could improve the screening process, especially in the areas where there's shortage of doctors, specifically by taking advantages of recent advances in machine learning and computer vision. So when you look into every diabetic patient, the screening is key to preventing blindness. The sooner you can detect it, the earlier you can intervene on the therapies that I just talked about. Every diabetic patient should be screened once a year. This is done with a special camera that takes a picture of the back of the eye, the fundus image from the retina perspective. An eye doctor then grades the image on a 5-point scale. They look for little things like hemorrhages. If you're looking at the screen on the right-hand side, is the little dots. They are the hemorrhages or fluid leakage. That is a signal of the prevalence of the disease in the eye. But as I mentioned, given the shortage of the doctors in many parts of the world, there's simply not enough specialists to be able to detect and look into the picture and detect the disease early. So nearly 45% of patients suffer vision loss before the diagnosis. This should never happen because this disease is completely preventable. So we wanted to look into applying the machine learning into computer vision, and we trained a deep neural net to help with this task. We obtained lots of images from the hospitals in India and screening provider in the US. We built a labeling tool and hired over 50 plus ophthalmologists to read the images and establish ground truth. In total, at the time, it was 800,000 plus images or diagnosis, which was necessary because of the variability in the grading of the disease. We then trained the model. This is the ground truth. Based on the images, this ophthalmologist advised us on the prevalence of the disease, no DR to mild, moderate, severe, and so on and so forth. We then use this data to train this pretty model and to predict a variety of outputs, including grade of the disease and some housekeeping labels such as image quality in the left or the right eye. This was the same network that is used in Google Photos as an example. If you use it, when we can recognize these pictures of the same people and used to classify dogs and cats. And now this is the use case where the same technology that Google has built for our own products applied to an industry and applied in this case to the field of ophthalmology, in this case retinal fundus image, can be detect and train the model. And the results have been promising. So how well did the system perform? Here's the figure from our publication JAMA. Y-axis is the sensitivity, x-axis is 1 minus specificity. The algorithm's performance is the black line. The colored dots represent US board certified ophthalmologists. Up and to the left is good. As you can see, we very closely match the performance of ophthalmologists. In fact, if you look at the F-score, we are just a bit above the median ophthalmology. This work was well received in the medical community. We are working with hospitals in India to see can we really bring the screening to the front line of the clinical workflow. These are still very, very early days. The promise of the technology is there. However, there's still a big gap between an algorithm is not enough. You really need to test it out in the field, and that's the work that we are continuing to do. So what's next? As we look into a world of healthcare where we can really augment that with technologies like this, we are looking into embarking, and we recently completed our first clinical trial with Arvind Eye Hospital in India, showing that the algorithm is on par with their current graders. There are 2 more trials in progress. Google's sister company, Verily, we are looking into deploying this technology across the world. And as I mentioned before, still very early days. However, a lot of promise, and the technologies like this, and there are many different fields in addition to ophthalmologies in the area of radiology, pathology, where we are learning from applying the machine learning in the field of healthcare to really advance our understanding of the disease, and especially in the assistant and early detection. But where we see the future, can it help with a diagnosis? It's still, in my view, a decade, a little farther than where we are today. But where it can help today is in the assistant, this assisted read, that where we can actually help the ophthalmologist or this technician who are reading the retinal fundus image to get to the same understanding, and helping them, okay, the algorithm has detected number 3 as the severity, and it needs to be seen by a specialist. Can we track and identify those cases so that in the areas where there is shortage, people are able to see the doctor and are put on fast track? This is our hope. However, it is important to remember that technology is just an amplifier. it scales what you apply it to. So our hope and aspiration for healthcare is the world of healthcare is filled with disparity. There's a role for technology to play in bringing the stakeholders and community together to create meaningful innovation and inventions. And we want to do it with all of you. The work is not done. And it will take more than a tech company. It will take students like yourselves. It will take innovators. It will take partnerships across the entire healthcare ecosystem to bring them to life. So with that, I would close my talk and stay well and be well during these trying times. Thank you.